All right, we are back for some more math. Sarah the Triceratops could not be here today, so I have brought Taco Cat in her stead. Hello, I am Taco Cat. Okay, Taco Cat's going to help us review how to use arrays to show multiplication, and then we're going to work on the commutative property. What is the commutative property? Hold on to your fillings, Taco Cat. We'll get to that in a minute. So let's look at my array that I've drawn here. I have 1, 2, 3, 4 rows, and each row has 3 in them. So I can count the rows to see what 4 times 3 is. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 4 times 3 is 12. Correct, Taco Cat. 4 times 3 equals 12. Now, I'm going to draw a totally different array, and I want you to see if you can tell us what is the same and what is different about it. Watch carefully. All right, let's show our multiplication sentence first. I have 1, 2, 3 rows, and I have 1, 2, 3, 4 in each row. So right now, my multiplication sentence is getting ready to show me 3 times 4. I think I see a pattern. Wait for a second, Taco Cat. We're going to solve it first. So let's count our rows. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 3 times 4 equals 12. Do you notice something about these two arrays and these two multiplication sentences? I do. Taco Cat, would you like to show us what is the same and what is different? Of course. Come closer. Behold, each of these equations has the same numbers. 3 and 3. 4 and 4. And the products, the answers, are the same. 12, 12. They have the same numbers, but in different orders. Taco Cat, out. Hey, thanks, Taco Cat. So here's what the commutative property means. It's like a rule, a trick for multiplication. It means if I take the numbers in one multiplication problem, 3 times 4 equals 12, I can just flip, whoosh, whoosh, do it with me, whoosh, whoosh. I can just flip those numbers around, whoosh, whoosh, and I'm going to get the same product. I'm going to get the same answer. So if I know what 3 times 4 is, then I know what 4 times 3 is. Let's look at it another way. Hey, Taco Cat. So let's look at an array for 2 times 6 equals 12. I've made an array of crayons here. I have 2 rows with 6 crayons in each row. Now, watch what happens. Whoa, whoa, whoa. I turned my camera, but now I don't have 2 rows of 6. I have 6 rows of 2, which also equals 12. So I have the same array, but if I look at it from different directions, it changes the equation slightly, but the product is still the same. That is awesome. These directions say, draw an array and give the product for each fact. So first, I'm going to draw an array for 5 times 2, 5 rows of 2. 1 row of 2, 2 rows of 2, 3 rows of 2, 4 rows of 2, 5 rows of 2. And if I count them, 2, 4, 6, 8, 10, the answer is 10. Then I'm going to draw an array for this other fact. I'm going to draw 2 rows of 5. So here's 1 row of 5 and 2 rows of 5. Both of them equal 10. Here's another type of problem that shows commutative property. This focuses on the equal sign. It means these two sides of the equation are the same. So this one says 5 times 2 equals what times 5? What number would go there to make those two sides match? Well, we just did that problem. 5 times 2 is the same as 2 times 5. Those numbers switched around. Let's try the other one. We have 6 times 1 equals is the same as 1 times what? Well, if I take those two numbers and switch them around, I know that 6 times 1 is the same as 1 times 6. All the numbers are there, they just switch spots.